It's finally time to start stoichiometry. Now, stoichiometry deals with problems like this. If I burn 0.321 grams of C2H4, which is ethene, if I burn that many grams of it, how many grams of CO2 do I get? Now, when you have a problem like this, you first need to write a balanced chemical equation. Right now, I've written this, so I know burning is combustion. And if you're burning something, you're burning it in oxygen, right? So this is your generic combustion reaction. So there's ethene, C2H4, plus O2 goes to CO2 and H2O. That's just combustion right there. So, as it's written, this is not balanced. And that is your first thing you need to do with stoichiometry, is make sure your chemical equation is balanced. So I'm looking at carbons. Carbons aren't balanced. I have 2 over there, so I need 2 over here. I'm going to move on to hydrogens. I have 4 on this side. I need 4 over here, so I'm going to put a 2. And I have a total now of 6 oxygens here. So if I put a 3 in front of here, I get 6 oxygens on the left. I'm going to double check, make sure I'm balanced. 2 and 2, 4 and 4, 6 and 6. Okay. Now I'm going to set this up like dimensional analysis. On the left-hand side, or actually before I do that, I want to write down all of my knowns. Sorry, I almost skipped that. You want to write down what you know and what you don't know. And I like to write it right under each of these. So I'm just going to start on the left side and say, okay, what do I know about this? What's given? Well, it says right here, 0.321 grams of ethene. So that's what I'm going to write right here. 0.321 grams of that stuff. How much of this do we have? Well, it's not stated, but it's implicit in the problem. Now, if you're burning something in air, so just think about this. If you go outside, are you going to run out of oxygen? No, because the air has plenty of oxygen. So if you're burning something, you're most likely always going to have an excess, unless it's stated that you only have a certain amount. So right now, we're going to assume that that is in excess. And over here, we don't know. It's not given, and all we know so far is what we start off with. And this is still unknown. That's what we're trying to find. So, now we're going to convert grams to moles. We're always going to convert grams to moles. With stoichiometry, we go from grams to moles, because grams don't tell us anything. Grams, remember, things don't weigh out right. This weighs a lot more or a lot less than this stuff. We have to go to moles to find out. So one more time, convert grams to moles. Okay. I'm going to set this up with dimensional analysis. I'm going to put what I know on the left-hand side, which is 0.321 grams of ethene. And then I'm going to put what I want on the right-hand side, which is grams of CO2, right? Because that's what it's asking. How many grams of CO2 do I get? That's what I want to know. So I'm going to put grams of CO2. Now we're going to use dimensional analysis to figure this one out. So the first thing we want to do, once again, grams to moles. So I'm going to put grams on the bottom and go to moles. And this is of ethene, C2H4. Okay, well, we don't know how much 1 mole of that weighs. So we're going to have to plug that into our calculator. Now, we're going to do this the easy way. We're going to go with the chemical formula, which is 2 C's. So I'm going to go 2 times the molar mass, which is 12.01, which is given on the periodic table. So 2 times that plus 4 times 1.008. I pulled those numbers off the periodic table, and it's as easy as plugging it into the calculator there. I hit enter. I get 28.052. So that's 28.052 grams of ethene in every 1 mole of ethene. Now what do? We've converted grams to moles, but we need to get back to grams of CO2. Well, it seems to me like we're going to need another conversion ratio. And we are. But where do we pull this ratio off of? Well, that's where this comes in handy. This balanced chemical equation tells you ratios. So, if we're starting with this, right, and this is all balanced, we know that for every 1 molecule of this, we're going to get out 2 molecules of CO2, right? That's just how the equation balances out. And that makes sense because if you have 1 molecule of ethene, which is this right here, and you burn that in O2, the only way that this is going to even out is if you get 2 molecules out. So I'm going to put what I don't want on the bottom, which is moles of ethene, moles of C2H4. And I want to go to what, and of course with everything with dimensional analysis, what we don't want goes on the opposite side, and then we put what we want on this side. So we want to go into moles of CO2. Now what's the conversion ratio? Well, for that we're going to look at these coefficients. Now this one doesn't have a coefficient, so it's assumed to be 1, so I'm going to put a 1 there. This one is 2. And does that make sense? Yeah, because every 1 mole of this, you're going to get out 2 moles of that. That's what the equation tells you. So now we have moles of CO2, and we need to go to grams of CO2. And is there a way to do that? Well, yeah. Again, we need to get another conversion ratio. So I'm going to put what I don't want on the bottom, which is moles of CO2. And I'm going to get into what I want, which is grams. And how do we do that? Again, we use the periodic table. I'm going to go with the formula there. So I have 1 carbon, so I'm going to put 1 times the weight of the carbon, which is 12.01, plus, we have 2 oxygens, so I'm going to go 2 times 16.00, which is the weight. So the total weight of 1 mole of this is 44.01 grams. 44.01 grams in every 1 mole of CO2. So now it looks like I've converted everything. I think I'm where I want to be. We wanted grams of CO2, and let's see. We went from grams of ethene, and we had grams of ethene here, which cancels. We had into moles of ethene, which cancels out with moles of ethene. We went from moles of ethene to moles of CO2, which cancels out right there. And now finally, we're in grams of CO2, which is what we wanted. So let's plug this into our calculator. We're going to go 0.321 times 1 divide by 28.052 times 2 divide by 1 times 4.01 divide by 1 equals 1.0072 16 and so on grams of CO2. Now, significant figures. What do we have here? We have 4. We have a lot there. So we're limited here to 3. What about this? Well, that's an exact measurement. That's just like saying 5 fingers on a hand. We don't need to worry about that. So we're limited to 3 significant figures. So we're limited right there. So we're going to go 1.01 grams of CO2. And that's our answer.